Simplify 8 over 2x squared plus x plus 3 over 6x squared plus x minus 1. Okay, so we have two rationals here, rational expressions. First 5 letters spell ratio. So we're talking about a fraction. This is a polynomial divided by a polynomial. Okay, so if we were trying to add fractions, because that's what these are, a over b plus c over d, we cannot combine them unless the denominators are the same, right? We need a common denominator. Okay, so we need a common denominator here. So what you would do for this little example, this easier example, is you would find the least common multiple of those denominators, and that would be your common denominator. So in this case, it would be b times d. So you'd have a over b, and you'd need the new denominator to be the least common multiple, b times d. So you'd multiply the top and bottom by d, and then you would do the same thing over here. You'd have c over d, you'd multiply the top and the bottom, in this case, by b. That way you're multiplying by the number 1 on each piece, and now their bottoms are the same. B times d is the same as d times b by the commutative property. So we're going to do the same thing. The problem is our expressions must be factored first. So we're going to have to factor the denominators of our expressions. So let's start with the first one. 2x squared plus x. Is there something we can factor out of both pieces? Do both terms have a factor in common, the greatest common factor? Yeah, they both have an x. So x. X times what gives me 2x squared? Well, that's 2x. X times what gives me plus x? Well, that's a plus. So that's the factorization of the first denominator. So this is 8 over x times 2x plus 1. Now we're going to look at this guy. Okay, so we have 6x squared plus x minus 1, and we're going to try to factor that. First question, can we factor something out of all 3 terms? No. Okay, then we say, well, there's 3 terms. Maybe we can factor this as a product of 2 binomials. Okay, so we're going to do this with the AC method, or factor by grouping. We're going to consider ax squared plus bx plus c. So when we do that, a is 6, b is 1, c is -1. Remember, when you do this, a and b are coefficients of x squared and x, respectively, and c is your constant. So for the AC method, we are going to look at a times c, the product, a times c. Well, that's 6 times -1, that's -6. Ignore the negative sign for just a minute. We're going to write all the natural number factors of 6. So we have 1 times 6 and 2 times 3. If there were more, you would write those as well. We see here that the last sign here, or the sign of c, is a negative. So that tells us 2 things. That tells us ultimately, when we end up factoring in our parentheses, signs will be different. That's the first thing it tells us. We're not there yet. We're not to the factorization yet. It also tells us that we will subtract to get the middle number, the middle term. Okay, so when we subtract, we're going to use different signs. So the first part tells us, right? Okay, and we want the signs, we want the biggest sign to be positive, because this sign right here is a positive. So positive, negative, positive, negative. Which of those, when you combine them, gives you a positive 1? Well, -1 plus 6, if you combine that, that gives you a positive 5. And -2 plus 3 gives you a positive 1. So we're going to use this combination. So we're going to rewrite 6x squared. Instead of plus x, we're going to write that as -2x plus 3x minus 1. So what we're doing is we are rewriting this middle term plus x as this difference of terms, -2x plus 3x. Okay, now we're going to factor by grouping. So by grouping, we are going to group the first 2 together. So we're going to group like this, and then we're going to group the back 2 together. You can use parentheses, but please be very careful if you do that. I'm going to use these little different ways of underlining, because if you use parentheses and you do 6x squared minus 2x plus 3x minus 1, if you don't do it correctly, you can change the whole thing. Your parentheses would have to go like this. I have a lot of students who put the parentheses like this, and then you've changed your whole problem to multiplication. Don't do that. It is safer to just underline. Okay, so then we say, what do the first two have in common? So 6x squared minus 2x, the greatest common factor of those is a 2x. 2x times what gives me 6x squared? Well, that's 3x. And then 2x times what gives me negative 2x? That's minus 1. Okay, then look at the back two. What do they have in common? Well, the greatest common factor there is 1. So I'm going to put plus 1 times 3x minus 1. Now notice, both of these have a 3x minus 1 in common. So we're going to rewrite the 3x minus 1. And then we look at the pieces that are remaining. We have a 2x plus 1. So that's what's going to go here. If you need some help on factoring by grouping, we have more videos over just that. Okay, so we have factored that denominator. It is 3x minus 1 times 2x plus 1. I'm going to rewrite that up here. So now we're going to find the least common multiple of those denominators, because we're going to build a common denominator. Okay, so there's lots of different ways to do this, and I think the easiest way that makes the most sense to students is to start with the first denominator. So we are going to write all the factors that are involved in that product of the first denominator. So x times 2x plus 1. So x, I'm going to put a little dot under them. I've used the x, I've used the 2x plus 1. You look at the second denominator. Are any of those already written down? Yeah, 2x plus 1 is already written down. Okay, is there a term in that product that has not yet been written down? Yes, we haven't written this one down yet. So that's why we're going to include 3x minus 1. Okay, so that's how you do it. You write down all of the factors in the first denominator, and then you look at the second denominator and say, is there something I have not yet written down yet? Something else that needs to be included. Okay, so this will be the least common multiple of my denominators. In other words, this is going to be the common denominator I use. Okay, so we're going to rewrite the expressions like this. But I'm going to multiply by a fancy number 1. So I'm going to look at the denominator I have here, which is x times 2x plus 1, and I'm going to say, is there another piece I need to include as well? Yes. I also need a 3x minus 1 in the denominator, which means I better also put it in the numerator. That way I'm multiplying by that fancy number 1. Does that make sense? I have not changed the expression. Still mathematically equivalent. Then I do the same thing to the second expression. So I had 3 over 3x minus 1 times 2x plus 1. Go and look at the least common multiple of your denominators. I have this and I have this already. This is the one I need to include. So if I put an x in the denominator, I better also put an x in the numerator. Okay, that way I'm multiplying by the number 1. So if you look, my common denominator is x times 2x plus 1 times 3x minus 1. It doesn't matter that the order is different because we have the commutative property if we're working with real numbers. So I want to remind you what the commutative property says. It says if we have a product a times b, that's the same as b times a. So it doesn't really matter that I switch some of the order here. Mathematically, those are equivalent. So we're going to rewrite one big vinculum. That fraction bar is called the vinculum. It's a fun word, vinculum. And we're going to rewrite one of the denominators. Mathematically, like I said, they are equivalent, so it doesn't really matter which one you choose. I just chose the first one. So if they have the same denominator, we write one denominator and then we combine the numerators. Okay, because what I've done here, step right here is I said if we had a over b plus c over b, we rewrote the denominator and combined the numerators. That's what we've done. Okay, so now we're going to get to distribute. So we're going to distribute this 8 into here. So we get 24x minus 8 plus 3x. All of that is over x times 2x plus 1 times 3x minus 1. Okay, so far so good. Now we're going to rewrite the denominator and we're going to combine the terms in the numerator. Look for like terms. So we have 24x plus 3x. So I'm looking at the x's. 24x plus 3x. That's 27x. And I still have minus 8. This is your final answer.